This conference will now be recorded.
And let me introduce our presenter today. Today we have our very own Alevskey. He has presented before. He's always an amazing presenter. And today he's going to talk to us about Kubernetes security, something that is very relevant. I'm sure many of you have a lot of questions. Please type them and wait until the end. Try to mute yourself too, if you can. If not, I'm gonna have to if you're making a lot of noise. And he's been with us for now over a year, so he has presented several times, always giving us some great content and great technical skill and knowledge. And with that, I'm gonna give him the floor. Thank you very much, Lenny, and the floor is yours, man.
Awesome. Thank you very much, Rod. So, okay, let me try to share my screen. Then Max, I think, yeah, it's asking me for permissions. Give me 1 second.
Mm-hmm. You may have to restart the client. I had to do that earlier. Where
Yes,
if it's
yes.
is that a Mac?
Yeah, I will be right back in 1 second.
You're gonna have to give it permissions. There you go. So he should be back.
Yay, came back.
Yes. Okay, excellent. Let me make you a presenter and go for it, dude.
Okay. Okay. Screen. Okay. It's complaining again. Give me 1 second.
Yeah, and accessibility, add go to meeting, and then as soon as you do that, it's gonna tell you that you need to restart, and then you will restart, and that's it. You'll be able to do it. You're trying to share your screen, right?
Yeah, I already did that, and now I check the box, so I give permissions. Let me. Yeah, it's working now. Okay, perfect.
Awesome.
Okay, let me know you guys can see my screen.
You're good to go.
Okay, cool. Let me move these things a little bit. Okay, present. Let me pull out my notes. Okay, cool. I'm all set. Okay, thank you very much, Rod, for inviting me. This is my Google Hub. Okay, so yeah, I'm going to talk about Kubernetes, specifically the security part, because I think it's very relevant. Like a lot of companies are using it right now, and basically, yeah, it's like a technology that has been like a few years for now, and is every time like more and more companies are adopting. So yeah, first of all, a little bit about me. You already introduced me, but my name is Lenin. I'm from Mexico. I live here in the Bay Area. I'm working as a security software engineer for a startup. I do open source, and yeah, basically I'm crazy in love with cybersecurity, everything. Like literally, I never stop talk. I cannot stop talking about security. And yeah, that's my passion. So yeah, what is Kubernetes anyway, right? Like a lot of people is talking about this. A lot of companies wants to get to deploy their applications and system in Kubernetes, but what it is, right? It is secure. Like what can you do and what can you not do with Kubernetes, right? So essentially, Kubernetes is like a orchestration tool, right? That allow you to deploy applications in your private cloud or in your public cloud or hybrid cloud. So you can think about Kubernetes as a framework for building distributed systems. What do this mean? Like you can build infrastructure like this diagram. You can logically separate your applications between namespace, and then you can deploy as many copies or replicas of your application. And basically, the reason why it's so popular is because it's very easy for developers to to achieve this, right? Like basically with a little bit of code, you can deploy hundreds of replicas, you can escalate up and down, and everybody's happy, right? So yeah, it's basically more power for developers. And a little bit of details or history. It was released by, I think, Google in 2014. Nowadays, it's being maintained by the Cloud Foundation, the Native Cloud Foundation. And a lot of people is start to calling Kubernetes like the operating system of the internet, right? Why? Because you write your application once and then you can deploy everywhere, right? As long as it's running Kubernetes and you have like a container runtime, your application is going to run fine. And yeah, the next thing is, before talking about the security part, I would like to introduce you to the Kubernetes primitives, which is basically the language of Kubernetes. So usually when you want to deploy an application in Kubernetes, you need to think about services, deployments, pods, stateful set, config map, and all of that, right? So what you need to do is first you start by creating a service. So the service is basically networking configuration, is IP table rules that are generated automatically by Kubernetes that tell how to route traffic to your actual application, right? So the service will tell, hey, Kubernetes, please route these packets, route this traffic to these containers with the label application 1 or application 2 or whatever, right? So yeah, the traffic goes to the pod. And then what is a pod? A pod is a group of containers. So an important thing about here is that pods or the containers inside a pod share many things. Like for example, the networking namespace. They can also share, if you want, the file system namespace, right? But basically, this is how you interact with your application. The request incoming from the request and then arrives to the pod, and then from the pod to the specific container inside. Then the next important thing is the deployment. The deployment here is basically like a manifest or a series of rules that will compare the current state with the desired state. So in this example, I'm saying I want this application to run with 3 replicas. So if one pod gets down, like let's say because there is a networking issue or the actual node, the physical machine in which that pod is running is dead, Kubernetes will be smart enough to reschedule deploying a new pod on the next available machine, right? So remember, deployment is basically a comparison between the current state and the desired state. And after that, we have the next interesting concept, which is the config map, which basically allow you to store kind as a database or data store fashion way, like configurations. And then they have secrets as well, right? Which are not really secure, because the main difference between config map and secret is when you store something in config map, it's going to be stored as plain text. And when you store something as secrets, it's going to be base64 encoded. Then after this, we're going to see where are those secrets stored. But basically, this is like a very simplified example of how can you run your applications in Kubernetes, right? Remember, you need 3 things, at least: services, deployment, and pod. And of course, there is many other primitives like certificate signing requests, like network policies, like pod security policies, but this is the more relevant. So, okay, now that we know the primitives, let's talk about the components. So yeah, remember the diagram that I showed you? In reality, like under the hood, you will have like a bunch of servers. So Kubernetes basically distinguish between 2 types of servers, which is the control plane or masters, if we can, if we want to see it that way, the master nodes, and any other nodes, the node components. So the difference between these 2 kind of nodes is going to be the kind of processes or program that are running. Like for instance, the master node, the control plane, will run the kube API server, etcd, kube scheduler, and kube controller. So what are these? The kube API server is like the main interface for you to talk to your cluster. Basically, when you want to deploy something, You put all your whatever you want on a YAML file, like please Kubernetes deploy this application with this image, how many replicas, and then it's the job of the Kube API server validate that YAML and make sure it's right, and then everyone is going to be happy, right? Then etcd, we have etcd, which is the data store used by Kubernetes by default. So this is a distributed key value store that is going to be deployed as along with Kubernetes, and all the configurations, all the config maps, all the secrets are going to be stored there in etcd. Then we have the scheduler component. The scheduler component main job is to, whenever Kubernetes wants to deploy an application, the scheduler will make sure to deploy on the best node possible. And it can, like more advanced deployment strategies allow you to add rules and validations, so you can deploy your applications in many different ways. But once your application is deployed, then it's the job of the kube controller check the current state with the desired state, right? This is the part I told you about, like what let's say one of the nodes is down, all the application living there needs to migrate to a different node, right? So what all these four components have in common is that they require like elevated privilege, right? To run on this machine. So this is very interesting. Then we have the node components. The node components doesn't have that much privilege, but still they have interesting stuff. Like for example, they have the kube proxy. The kube proxy is basically a component that will route traffic to an application. So in this example, any of the nodes that are here, if they are exposed to the internet or to a client, and if they receive a request that has to be routed to an application that doesn't live inside that particular machine, then kube proxy will be smart enough to forward the request to a different machine that contains that application, right? So this is the main, the main purpose of the kube proxy. Then we have the kubelet. The kubelet is basically the Kubernetes agents, right? A Kubernetes agent will go and talk to the master and receive commands and basically monitor all the state of that particular node, like how many pods are living there, like and also information about the particular machine itself. And then finally, we have the container runtime. So when we say container runtime, we usually think about Docker, which is just one of the most popular, but nowadays I think is being or is getting deprecated. But yeah, I have another talk about container runtime in YouTube, you can check it out. But yeah, basically the container runtime is a software that controls and manage and create containers, right, on a machine. So yeah, this is the basic theory of Kubernetes. So with this, we should be good to go. And yeah, now that we know that, I want to start, I'm going to talk about the Kubernetes most common attack techniques. And there is a lot of stuff that you can do on Kubernetes. But give me 1 second. I think I'm missing a slide here. Yeah, I'm missing one slide here, which is the actual the threat matrix. Yeah. Anyways, let me show you the article. All this talk is based on this article from Microsoft, which is these guys put together a very well very well explanation post about all the threats in Kubernetes. So yeah, they start observing that Kubernetes is getting more and more popular, right? So they put together, they analyze and they identify like common categories on, like whenever somebody is attacking a Kubernetes cluster, they analyze and they identify 9 steps, like from getting access to the initial access to the cluster until cluster takeover or destroying information in the cluster, right? So yeah, like these 9 steps cover like the most popular techniques, like since initial access to impact. And then this was last year. I think they published this article in April 2020. And then because Kubernetes is evolving and the attacks are evolving, they write a second article with an update. Let me, yeah, with an update that basically they deprecate like old techniques and they added new techniques. So I'm going to talk about these techniques here. So previously it was 9 categories, now it's 10. They added collection that has to do with collecting information from inside the cluster, right? So the first one is the initial access. Let me go back to my presentation. Okay. Okay, so yeah, there is a lot of similarities on how do you attack a Kubernetes cluster, like to how do you try to compromise a machine or how do you try to compromise a network. Like everything starts about getting the initial access, right? And one way to do that is basically because more and more Kubernetes clusters are deployed on the public cloud. Like, I mean, Amazon, Microsoft, Google, all those guys like offer you like manage like Kubernetes clusters that they manage. So if you compromise a machine that has some cloud credentials and then you access to the cloud console and you have enough power to go basically to see all the infrastructure of a Kubernetes cluster, then you are in, right? Another very interesting way is like via compromise image and registries, right? Why is that? Because a lot of people deploy container images from public sources that you don't trust usually. And basically what you are doing is you are downloading code and executing that code inside your cluster, right? Doesn't matter if you put like firewalls outside of the cluster or you block all incoming communication. As long as you have like as long as you pull some code into your cluster from an untrusted source, you are going to give access to the attacker, right? The third way is via a kubeconfig file. So a lot of people that work in software engineering know that this file contains the credentials for you to connect to a cluster, right? There is an official tool from the Kubernetes team called the kubectl or kubectl, which is basically the command line interface for you to interact with the Kubernetes cluster. So if you steal this file from one of the developers' laptop, then basically you are stealing credentials and you can issue commands and you can retrieve infrastructure information. And yeah, that's another way to get inside a cluster, right? The fourth way is via application vulnerability, of course. So we developers write applications, but those applications sometimes are exposed to the internet. So if my application has a vulnerability that allows an attacker to execute code inside, then that's the first step, right? He's going to be inside the cluster. And the last one uses to be a Kubernetes dashboard, which nowadays is deprecated in favor of something worse, I think, which is nowadays there is a lot of companies that use focus on deploying Kubernetes, right? Like they sell you support on how to manage your Kubernetes cluster for your organization. And they create like management dashboards. Like, for example, we have like Rancher, we have like Kubeflow, we have the Kubernetes dashboard, which is basically front ends to manage your Kubernetes cluster. So sometimes people expose those front ends to the internet without authentication, and that's a game over, right? Because you can do anything on the cluster from there. So once you have the initial access, the next thing you want to do is start executing your code inside the cluster, right? So if you have access to the kubectl command, and let's say because you steal the kubeconfig file of one developer, you are in the developer's machine, but with the kubectl exec command, you can actually get a shell from inside of the containers running on the Kubernetes cluster, right? So it's very easy. It's just a single command, and then you are inside the cluster, right? So another way is you can deploy your own container. If you have credentials power for powerful enough to deploy your own container, then you can run code inside the Kubernetes context. The tier one, of course, application exploit, remote code execution. If the vulnerable application allow you to run commands, then like you can pivot, right? Like you are outside the cluster, but you can trigger like commands, and you can scan the internal network, and then you can communicate with the internal Kubernetes services and do more interesting stuff. The fourth one is something that is very common that I see organizations do, which is SSH server, but they deploy a container because they want people to have access to the to have access inside the Kubernetes cluster. But I think for them it's more easy just to deploy a SSH server and from them issue commands. So if somebody brute force that, then they are automatically inside the cluster. And the last one is something that got added in this version, which is the sidecar injection, which basically is taking advantage of how Kubernetes work, which is what I mentioned in the past. You have a pod, but this pod is like a group of containers, right? You can have many containers inside a pod, and this is getting more and more popular because let's say you are monitoring your applications, and every time you go and tell Kubernetes, hey, give me how many pods I'm running, it will give you a number, and maybe that number is the number that you are expecting, right? But if you don't pay attention, like those pods can run more containers than the number that you are expected, right? And you can ignore that, and maybe an attacker deploy a malicious container inside an actual pod, right? An actual application that is running there. So this is another way to execute code. Then once you already execute code, then the next thing you want is persistent, right? How can I go back to the cluster if I go disconnected or somebody attack me? How can I maintain the hack, right? So yeah, as I was mentioning, backdoor containers. If the Kubernetes administrator deploys an image from a public repository, then you can modify that image and add your own backdoor code there, yeah, or your malware or whatever, right? Another interesting one is the readable host path mount, right? Because containers and pods support mounting actual physical volumes from the machine, the physical machine. If the Kubernetes administrator mount a very critical path, like for example, the file that manage cron jobs in Linux, then the application running there can make changes to that file, and those files will persist on the machine, right? So he can persist the attack there, right? There is another primitive of Kubernetes, another concept, which is the Kubernetes cron job, which is basically operations that Kubernetes will do on a certain time, right? So you can manage, or you can like schedule, like download this deploy this malicious container, but not right now, like wait 5 days or wait any amount of time, right? So deploy it like on the weekend, right? At 5 a.m. when nobody is looking, right? So that is also possible via Kubernetes cron job. And the last one, which is one attack vector or attack technique that got added this year, is the malicious admission controller, which again is taking advantage of one of the Kubernetes features, which is the admission controller, which is basically a software component that will be sitting between the client and the API server. And what it's going to do is going to receive a request, it's going to analyze the request, and it's going to mutate it and then send it to the API server. So that way you can, like every time a developer wants to deploy a specific application, you can sneak or you can add your own malicious container inside their deployment, right? And he will not know. So yeah, this is a new, very smart way to do it as well. So yeah, after that, once you have access and you have persistence in the cluster, the next logical step is to privilege escalation, right? So how can we do that? So Kubernetes privilege, Kubernetes use tokens and a concept that is called service account. And service account has many different powers in Kubernetes. So if you're inside a cluster and you know for a fact that another application require more privilege to do their job, like for example, I'm on a cluster and I know there is a container that is running Jenkins, and I know Jenkins require elevated privilege, so I have to attack that container, right? Because then if I'm able to go inside that container, I can steal the token, and from that I can continue escalating, right? The next one is called the cluster admin binding. I'm going to talk a little bit about more about the cluster roles, but cluster admin binding is a default role in Kubernetes, which is very powerful, that basically allow you to do anything. So if you are inside a Kubernetes cluster and there is an application with a service account token that has the cluster admin role, that will be like the jackpot, right? Because if you compromise that container, then you will be able to do anything that you want on the cluster. So usually attackers are looking for this kind of privilege levels, right? Hostpath mount, again, as I say before, so because you have access to the actual physical machine, you can like do stuff like I mentioned, like modifying, create a new cron job, right? Or read a sensitive file, or basically try to escape the container into the physical machine, right? And once you're in the physical machine, you can talk directly to the kubelet service and many other services used by Kubernetes. And the last one, which is also very public cloud related, is the access cloud resources, which is usually when Kubernetes is deployed in a public cloud like Azure or Google, those guys are their own services that allow with the integration, right? So for example, they have like a metadata services, they have like a Amazon, like they have many other cloud resources like S3 storage, like deploying EC instances, like creating groups. So a compromised container can also give you access to those other resources, right? So you can start escalating more. So yeah, this was privileged escalation. The next one is defense evasion. What can we do to like avoid detection, right? So usually one thing attackers do is to clear container logs, right? So this may be deleted if the logs folder is mounted in the container. Then you can go and delete those files, and the changes will persist. There is another way in which Kubernetes logs do the logging, which is Kubernetes events. The command is kubectl get events. But if you compromise powerful, if not enough credentials, then you can delete all those events, right? And the developers will not know what is happening there, right? Usually in those events, you will see something like this pod got created, this pod got deleted, it got something failed because of a reason, whatever, right? And the next one is someone that is very, I think is very funny and smart, which is container name similarity. So usually when you deploy pods via a controller, such as the replica set controller or stateful set controller or deployment controller, you are not creating the pods directly. It's a Kubernetes component. So this component will use the name of the deployment, and then we'll add like a suffix with a random string. So what you can do is, if you have credentials that allow you to create pods, you can define whatever name you want. So you can deploy your own malicious container or pod in the kube system namespace, and you can make it look like it was part of the same group of pods, right? You can choose a similar name, like kindnet dash and whatever random thing you want, and then this will be very difficult to detect, right? Because everything looks the same. And the last one is connect from proxy server. This one, I think it has to do with the kubectl proxy command, which is it will mask or hide your real IP address, right? Instead, it will take the IP address of the machine that is running the the actual kubectl proxy command, which maybe is the developer's machine, right? So that was defense evasion. The next one is credentials access. And here is where things start to getting interesting, right? Because remember, I was talking about config maps and secrets. So by default, a service account token on an application will allow you to list the secrets and config map of a particular namespace. So if you compromise an application, you can use that service account token to go and talk to the API server and ask for the other secrets on that particular namespace, right? So usually secrets are used to store like database credentials. Also, Kubernetes has this concept of a internal certificate authority. So if there is an application deployed with TLS, very probably that the certificates, the actual public and private key, are going to be stored as Kubernetes secrets. So you can get those, and then you can decrypt the incoming traffic to that particular application. Because this list was based on Microsoft blog post, so they talk about the service principal, which is a concept they use on their Azure Kubernetes service, which is a special file that contains some credentials and is mounted on every pod on the cluster, right? So if you are able to get that file, then you basically can access to cloud resources. The next one is service account token, which is by default, service account token will be mounted to all the pods on the cluster under this path. So you can, if you have like command execution on that container, you can go and read the token, and you can basically and literally use do curl commands to the API server, Kubernetes, and include this token, which will be your authorization, and start retrieving information, right? Of course, depending on the level of access of the token, but this is like very important, and it will let you escalate privilege and lateral movement. Also, as I was mentioning, applications credentials are usually stored in config maps and secrets. So yeah, there is going to be a lot of stuff there. And then we have access management identity, which is also a public cloud concept, which is basically applications that want to interact with cloud resources, such as database managed by the public cloud, or S3 object storage managed by the public cloud. So if you compromise that container, that application, then you automatically will also compromise the credentials in which that application has access, right? And again, our good friend, the malicious admission controller, leverage on the fact that this admission controller will intercept all the YAMLs that are incoming, then you can inspect and look for credentials there, right? Like, like you can look for secrets or config maps on, and also I'm going to talk about a little bit more about the image pool secrets, which is a credential for downloading images from private repositories. So as you can see, there is many different ways, right, to get credentials when you have access. The next one is discovery. So discovery is once you are inside the cluster, what can you see, right? Because you are already inside the cluster context, you can scan the network, like get information about any other pods, any other applications, or you can go and ask directly the Kubernetes API server, right? If your service as account token is powerful enough, you can tell Kubernetes, hey, give me all the services, and it will return you a list of services and which pod they are running, right? You can also ask the kubelet API, like a kubelet API has like a port exposed on the actual physical machine that doesn't require authentication, and can also give you information about what's the current pods running on that particular machine, and also some information about the current node. So yes, I was saying network mapping, Kubernetes dashboard. If that thing is deployed there, basically you can do anything you can do through the CLI, but in a graphical way. An instance metadata API, which again is very dependent on the public cloud. So those guys add this because of the integration and because sometimes you as a developer wants to get information of metrics of the actual physical node, so your application can make decisions, right? And yeah, lateral movement. So yeah, what can you do? As I was saying, if you compromise a container, it's very probably that you can have access to the cloud resources using that by that container or that application, right? You can try to use the service account token to read secrets and credentials from other applications and then escalate or move to that application container, right? You can try to see what is inside the cluster internal networking. And also, the last one is very interesting, and it was added in the last version of the threat matrix of Kubernetes, which is the core DNS poisoning, which is core DNS is basically a software component DNS server used by default in Kubernetes. And basically, as the name says, is manage the name resolving, right? The host name resolving. So core DNS store the configuration in a config map file that is called the core file in Kubernetes. So if you have credentials that can go and modify that file, then you can poison basically the core DNS answers, right? So yeah, it's very interesting. Like when I read about this, I went to my local development cluster and I start playing there. And then we have a collection, which was the new category that was added. And as I was telling, like usually people deploy images from the public cloud, but they can also deploy from private cloud. But in order to do that, they have to set credentials, right? And these credentials are created as a Kubernetes secret. And then those credentials are attached to the pod using the image pool secrets directive. So if you have access to, to read this kind of YAML files, then you can base64 decode this and has access to, to extract private images. And the last one is the impact, right? Now that an attacker is able to do all of this, he can do like basically three things, right? He can do data destruction. Like let's say there is another concept that I didn't mention at the beginning, but the way Kubernetes persist information from containers is via persistent volumes. So if you have access to Kubernetes with elevated privilege, you can delete persistent volumes, and you basically that is destroying data, right? Resource hijacking, which is basically deploy like malicious containers that maybe you want to mine Bitcoin or Ethereum or any other cryptocurrency or whatever. So you can leverage the Kubernetes, the machine resources for you to do stuff. And the last one, which is denial of service, which I think is very easy to do in Kubernetes because I can imagine a scenario in which there is a service that is routing traffic to many pods using a label. And with a minimal change on that service, which is changing the label, like adding a typo to that label, then incoming requests will not be able to reach the pods. And from the outside, you're going to see like if the application is down, right? But if DevOps or developers go and see the cluster, they will see everything is fine, right? They will see the pods are up, the services are up, and everything looks fine. They have to go to the service definition and see the actual typo there, right? So that is one way to do denial of service. Another way is to go and delete directly the deployment. And when you delete the deployment, the pods, depending on that deployment, will also get deleted, right? Another one, which is very obvious, is if you delete the service, the Kubernetes service, then your application will be still living inside the cluster, but there is no way for Kubernetes to route traffic, right? Because it doesn't know how to react, right? So yeah, this is the impact. And yeah, now I'm going to talk about the defensive part. Now that I know how to destroy a Kubernetes cluster or hack a Kubernetes cluster, let's talk about what are the building defenses, right? What can Kubernetes offer us in order for us to secure our Kubernetes cluster? So there is three things. The first one is security context for pods. So if we are building an application, like we want to, like following the principle of least privilege, we should deploy applications that are not running as root, that doesn't have more capabilities than the one that is needed, probably with secure computing profiles or AppArmor profiles and stuff like that. And lucky for us, Kubernetes allow developers to do that, right? Or those people to do that. So you can add this type of security directly into the pod using these directives here. So there is more, but this is like the most common one, which is allow privilege escalation. Will tell Kubernetes that the processing inside that container cannot be more powerful than the actual process, right? That start the container. Then capabilities is again, I talk about this in a previous talk, which is like what powers does the process of your application has access to, right? Privilege basically is if a container has a privilege flag, basically it will have access to all the physical machine namespaces, like the network namespace, the process namespace, the file system namespace, and all of the other namespaces. And now, then you can, by default, is going to be root. If you deploy an application to Kubernetes, by default, you will see that has root access. But if you define like any other ID, like a random ID, it's not going to be root, it's going to be another user. And then we have, option for you to do the security enhanced configuration of the second profile. But remember, if you are deploying application, you need to do this for each application you want, right? Like you are putting the security directly into the deployment or the pod in this scenario, and that is not the idea, because people make mistakes and somebody can ignore this, and then the pod is going to be deployed in an insecure way. The next defense is the networking policies, because we already talked about that by default in Kubernetes, all pods can talk to any other pod, right? There is no security enabled by default. So there is many things that we can do, right? The first thing is we need to install a CNI driver. CNI driver means Container Network Interface Driver. And yeah, there is many different flavors, but the most popular, I think, that I see in the enterprise world is Flannel, Calico, and Istio. So Flannel is very easy to configure, very easy to start, but it's not very powerful. Then I think Calico is the next one. This one requires a little bit more configuration, but it's also very flexible, very powerful. And then there is Istio that is their own solution themselves, but they have their own CNI driver. So yeah, what network policies will allow you to do is basically define rules. So tell who can talk to who. And again, because in Kubernetes, everything is declarative, you can just say, I want a network policy that will apply to all the pods on the default namespace that have this particular label, right? And then you can define ingress and egress rules to tell who can talk to these pods in the default namespace, right? So in this particular example, we are saying that all the first of all, if you have a network policy, then the pods inside that namespace will be isolated. But then you can start giving access to pods outside based on rules. Like here, for example, I'm saying the pod with a role DB tag label can receive connections from a pod in any other namespace as long as they have my project label, right? So yeah, the pod on the right at the bottom can go and talk to the database under that specific port, but cannot go and talk to the front end directly, right? The front end, yes, can talk to the database because they are in the same namespace. And also the database can go and talk to all the other pods in a particular network segment. But the the front-end pod cannot do that because there is a rule that prevents that, right? So network policies will be the tool that allow you to block communications or map communications, right? So you can add more security to your cluster, and you can mitigate like a lateral movement with this. Then the last defense is pod security policies, which is probably the most secure way to protect your cluster, but also the more complicated, because this thing honestly is a little bit of complicated. There is many different concepts that I'm going to try to summarize. But essentially, pod security policies will different that the security context in which you go and add security to that particular deployment or pod. Pod security policies will add security to the cluster itself, and will, every time somebody wants to deploy an application, will run a series of checks, a series of rules. And if the pod doesn't match those rules, then it's going to be rejected, right? So all this is based on 4 different concepts, which is the pod security policy itself, which is a Kubernetes object that allow you to define the rules, like you know, I don't allow like privileged containers on my cluster, right? Or I don't allow pods running as root on my cluster, right? Then we have the cluster role. The cluster role basically is a concept in Kubernetes that allows you to group many different actions or verbs to resources. In this particular example, cluster role will tell you can use, which is the verb use, this pod security policy with this name, right? Don't worry, I have a diagram to show this like in a more graphical way. And then we have the cluster role binding, which is going to bind an actual cluster role with a resource. That resource can be a service account or a group or any other resource. And the important thing is that cluster roles and cluster role bindings are not, doesn't depend on a particular namespace. So this will apply globally to the whole cluster, right? To all the deployments. But then we have a problem because if we create a rule, like very strong rule, then we can break our cluster, because there is, of course, some deployment that will require like more elevated privilege, like Kubernetes owned services, right? Like the kube controller or the core DNS, that requires more privilege. For that, we have the role binding, which is very similar to the cluster role binding, but it will affect only a particular namespace. So let's say, well, here I have some examples, right? What I already told you, like pod security policies will allow you to define rules. And here in this example, I have a security policy called restrictive that will tell you that privilege has to be false, host network has to be false, allow privilege escalation, the process ID namespace, IPC, all of that has to be false. Then cluster role will attach to that pod security policy via the use verb. And finally, I can do the cluster role binding and put together the cluster role and service accounts. So this will prevent any high privilege container to be deployed on my cluster. And this is one way to protect, right, my cluster from somebody to want to run like malicious pods. So the diagram will look like this, right? Pod security policy at the bottom, then attach and put together with via the cluster role and the group. Cluster role can have many different verbs and many different resources, but right now for this example, I only have restrictive. And then everything is put together with the cluster role binding. So if I do that, and then I want to deploy, let's say Nginx, but in this example, I'm using the host network true. Whenever the kube controllers try to run this, I'm going to get an error, right? Because he's saying that this deployment could not match any policy. And here is even giving me the reason, right? Like he's telling host network is not allowed. So I need to go and change that. But yeah, as I was saying, if I write like very strong policies, I may break my own Kubernetes cluster. So this is when I have to use the role binding. And here what I'm saying is I'm creating a permissive policy, which has allowed to anything, to everything in the cluster, right? And then I attach this to the daemon set controller, the replica set controller, job controller, and any other service account that I want. But, and this is very important, under the kube system namespace. So kube system namespace is the namespace used by all the Kubernetes services, because Kubernetes management tool run over Kubernetes themselves, right? So yeah, with this, my cluster should be working fine, and everybody's going to be happy. So yeah, we got to the end. So in summary, right? So first thing is done of course, in your production cluster. It's not a good idea to deploy images from untrusted sources, right? Because there is a directive that says image pool policy, and it can have like a value of always. So if a pod got deleted, it's going to try to delete even if the image already exists in the Kubernetes internal registry. It's going to try to download again the image from the untrusted source, and somebody can put malware on that image, right? And then can compromise your cluster. So it's better to try to use like a private registries for this. Another thing is try not to store sensitive data in Kubernetes secret, because as I was saying, the data is not actually secure, it's not encrypted, it's just base64 encoded. So instead of that, it's better to use like a tool like the kubectl, the kubectl controller, which is going to encrypt that information before being encoded, and then it's going to be stored on etcd, or use an external key KMS, right, to manage secrets. Of course, this will depend on the application and all of that, because it's adding more complexity, right? And the whole purpose of all these things, distributed systems, is that you have many different replicas, and if something is down, then your application will continue to operate. But what happens if the external KMS is down, right? Everything is going to be down. So you need to do like analysis there to have like a cost benefit. The next thing is protect your network communications. Choose a CNI plugin that supports networking policies, and do analysis like who really needs to talk to who, right? So create your rules there, create your networking policies, and with this you can mitigate, like if one application got compromised, it's going to be, but this application don't really need to talk with another very high critical application, so you need to protect that, right? Yeah, the fourth one is never use the cluster admin. As I was saying, the cluster admin is a cluster role that is created by default in Kubernetes and is very powerful. So if you put your hands on a service account token with this kind of role, it's basically a game over, because you can talk to the API server and start getting all the information and basically do anything on the cluster. So never deploy applications using this role, the service account token, and you will be fine. And the last one, which I think is the most important for this talk, is in production, you need to do the analysis and define a strong pod security policies, thinking about the principle of less privilege, right? With that, it's going to be harder for an attacker to escalate privilege and compromise your whole cluster. So yeah, this is all the resources that I used during this presentation. So yeah, Kubernetes, I'm not like a super expert on Kubernetes. This is something that I've been using for the last 2 years, and I'm always trying to learn. So I put the resources I use for this presentation here. And if you have like more that I can use in the future, I'll be happy to read it and also put it here in this list. And with that, I think we're in the end of the presentation. Thank you very much, Rod.
Thank you. That was an awesome presentation. So we can probably go over some questions. So let's take a look at this here is, can you tell us a little bit, actually, one that I actually oversaw. Can you tell us a little bit what's going on with Docker and Kubernetes? What's happening? What's going on?
They are deprecating, basically, I think it's the Docker shim component. They are deprecating that dependency in favor of use containerd, which is basically the container runtime, the official container runtime that Docker want to use. So I think they are going to deprecate it in Docker 1.21 or 1.20.
Is there a specific reason they're doing that, or?
I think I read this yesterday, but I think I forget. But it was saying like something that the article says the Docker shim, as the name implies, is like a temporary solution. So this is why we are deprecating. So yeah, that's the whole reason. But that doesn't mean that your Docker images will stop working, right? Because the whole container thing is based on a standard. So as long as your Docker your container runtime follow that standard, your images should work.
There's somebody here asking for the last page for the references, if you can. Yeah, to give
yes. This presentation I think will be, I will share with in the Slack channel, so you guys can take a look.
Excellent. I'll post the link along with the video. See if we can find. Are there any other new hardware features in Intel or AMD processors, such as secure enclaves, being used by Kubernetes?
Hardware features, I'm not sure. I'm not familiar with that. But I really am not familiar with hardware features.
Okay, here's a good question. In regards to vulnerability scanning for container images, can you talk about the maturity for current code scanning solutions for detecting malicious code in the image?
Yes, there is many tools, and I think let me quickly go to open this presentation. There is many tools for scanning your images, and also during runtime and during build time. So let me show you a list here. Container security tools. Yeah, you can use like auditd, which basically is like a checklist. So it will check for, like usually container images. When you want to deploy to production, you want to deploy an image that is that has hardening, right? Or a scratch image that doesn't allow you to execute commands inside. So there is many tools like Docker Bench, auditd, Dacta that will check for that. And you can implement all of this in your pipelines. So yeah, there is many options out there. You can use, this is like a more offensive security tool, which is Docker Scan. The distroless is an image, a tool that will take your image and will basically remove everything that is not needed. So that way your image will have many available tools inside in case somebody compromised the container running that image, right? But there is many different options. So yeah, distroless is maintained by Google, so it's a good tool. And
okay, yeah, go ahead, continue.
That's all that I have.
Okay, here's another question. Can service mesh add security measures to Kubernetes?
Yes, like I was mentioning Istio. So I was playing with Istio like a couple months ago, and Istio allows you to define their own CRDs. CRDs is this concept of Kubernetes for you to create like custom resource definitions. And the same way as network policies allow you to tell who can talk with who, also Istio allow you to do that. And Istio will also go beyond that. Will deploy like MTLS, like encryption between pods, because remember, by default, Kubernetes doesn't add any communication security in terms of encryption. So all the traffic inside the cluster is going to be plain text. But if you deploy your application with Istio, Istio will automatically add sidecar proxies. So each proxy will talk to like the pods will have their own proxy, and the proxies will talk to each other via an encrypted channel. And also, you can have metrics there. You can log who talked with who. You can see all of this in a nice dashboard. And you can define rules like same way as networking policies, like this namespace cannot talk with this namespace, or only the application, only the pod inside this namespace can talk to the outside world, stuff like that. So yeah, I think Istio is a very mature tool.
Here's the I guess a question that goes with it. Can you go over the sidecar injection again, please?
Yes. Yeah, this one, no? Yeah, this is the sidecar injection. You want me to explain a little bit?
Okay. Yeah, I think so. I think that's what you did. Yeah.
Okay. So yeah, like when you deploy applications in Kubernetes, Kubernetes will use this concept of pod. Pod is just a group of containers that live together and share networking namespace. And in some cases, they also share file system namespace. So attackers tend to do this to deceive. Like if I have a list, if I do kubectl get pods and I get 10 pods, then I can say, oh yeah, my applications are running fine, right? But those pods inside can have more containers, or can be a malicious container inside. And if I don't go there and look there, maybe this sidecar, this container that says sidecar can be like because they share the network namespace, can be sniffing the traffic receiving by this pod, right? Or can be reading the files. There is pods can be attached. You can attach volumes to pods. So the sidecar container can mount the same volumes and therefore read the same credential, the same information. So this is a technique that attackers are doing more and more, right? Are using more and more.
Great. Here's a comment. Check Falco for Kubernetes incident response. Here's another question. Any best practices to achieve visibility for security risk or exploits, given that pods and containers are short-lived, and it is hard to track them from logs since we have hundreds. I guess this is a person that's exposed to such a big environment, hundreds of containers, and they generate a lot of events.
Yes, usually when you hear Kubernetes, you will hear. Let me quickly look. My laptop is going to die. I think. Give me 1 second. So yeah, when you hear about Kubernetes, you will hear about also Prometheus, which is a service, a very popular service that will collect logs from metrics exposed in your services. So yeah, like there is like, I think one good practice is to store logs outside of the cluster. So that way, if somebody has access to the cluster, like he can delete all the logs of the cluster, but not the logs that are outside in another system, right? So you can use Prometheus to track all of that. And I think also Splunk, right? Splunk do login monitoring, and you can do analysis on that. So there's
a Splunk. There's actually a Splunk utility that is you had to sort of install it in the containers, but yeah, it gets very deep visibility into containers, but you still had to. There's some work, right? You had at least you get the logs, but you still have to do some work on the analysis, and the depends on what you're actually trying to target.
Correct. Yeah, and yeah, I think a lot of solutions like this, like even Istio has many different services.
Hold on, they're saying that they're just seeing a black screen. Sorry, I thought.
Oh.
Yeah.
Okay, let me share my screen again. Yeah. Can you see it now or?
Yeah, yeah, I can.
Okay, cool.
Click.
So yeah, like, yeah, right now I can think of Prometheus, Splunk, Istio. Istio has many different services. Networking policies or networking monitoring is only one thing that they offer, but they also has like this dashboard that shows you what is going on between in terms of communication between pods. So yeah, there is you can use a Prometheus or Splunk or Istio. I can go and investigate a little bit more on that and then post it on the Slack channel. But yeah, I think Prometheus is the thing that is, in terms of observability, the thing that is most popular.
Uh, Actually, Falco runs as a daemon set in the node. So in that way, they monitor the pods running in. And they have a lot of security rules to identify things like, say, the container compromise or privilege escalations. That's a good tool. And commercially, Prisma Cloud also has similar feature. They also run as a daemon set.
Awesome. I didn't know that. Thanks for sharing. So
Thanks,
yeah,
Prasad.
yeah, it makes sense. Yeah, these tools, yeah, will run in the physical node then, right? And we'll monitor at the container level, I think, with the Docker daemon probably. Or,
There's somebody
nice.
making a comment here. I saw some folks replace Prometheus with Dynatrace.
Dynatrace. Yeah, I think, yeah, Dynatrace is also a metrics monitoring tool. I haven't used it myself, but I think it's similar to Prometheus. APM.
Any other questions? This was an incredible presentation, like always, dude. You always knock it out of the park.
I think I lost audio.
Yeah, we can still hear you, but you sound far.
Can you hear me now?
Yeah, it's a little.
Okay, yeah. My AirPods died, but I have this.
Yeah, that happens.
Yeah. Yeah, I don't know if somebody asked any more questions. Or...
Datadog. Somebody is actually mentioning Datadog.
Yeah. I used to work for a company and we use Datadog again a lot. Sorry, we use Datadog a lot. And there was also another tool called Sumo Logic. Sumo Logic also, they have like a SDK, and you as a developer can integrate that SDK in your application and send logs directly and allow you to do like filtering and analysis. So yeah, there is two more, Datadog and Sumo Logic.
That's great. So if there are no other questions, this was again an amazing presentation. I'm actually putting a new invitation in the chat for everybody that wants to join the Discord. Remember, we keep in touch basically daily, 24/7 via our Discord or Slack. There's been some rumors of the purchase of Discord by Microsoft. So we still have both of them, and we're going to be monitoring and see what happens. But please join us. I believe we have a very interesting and exciting talk. Our next meeting, which is hacking satellites. That will be a first one in Pacific Hackers, and I'm really looking forward to see this presentation. Remember, join the Vegas 2021. People are starting to organize and prepare for this event in Las Vegas, and many of us will probably be there, and we'll see what we can do. Other than that, I'll thank you very much, guys. And